with you. Okay. So let's start the session. Okay. So in last class, I made okay. I made a network. I built a network like this. I put a switch and also put some PCs. And after that, I connected all these devices by using the cable. And after completing after completing the configurations, we get LAN network. Okay. So the today's topic is about if I choose two different LAN networks. So how do I make how do I communicate between both of them? Okay. So the first topic is about like if we have two LAN networks, then what are the methods or what are the way that we should follow to share information between them? Okay. So if you see here, I make a first LAN network, which network is about 192.168.1.0 and here is a second LAN network. There is another LAN network. Switch and I also choose some PCs. Okay. So now I also connect them using the wire. Okay. So now you can see for this LAN network, the network is 192.168.2.0/20. Okay. So now just configure the IP addresses over the systems, IP configurations. Then I the configurations like this. And the last one is about the desktop. Okay. So yesterday I told you that to negotiating or to doing or to sending information through this different through this different LAN network, then we have to choose a router, and we simply connected both these network through this router, and after that we have to configure the IP addresses over the interfaces available on router. As per that configurations, router get both the LAN networks informations and create a routing table on the behalf of this routing table. Both session in this particular classes. Okay. So first thing is about the two basic structural model, which is known as the OHI model, and the second one is the TCP/IP model, which is carrying the most important topics relevant like the IPs or some protocol related informations about them. Okay, so that's models are specifically used to define how devices are connected with each other and how they form or how they negotiated information between them by using this model. Okay, so we are starting discussing from these models. Okay, after that we are continuing with our network fundamentals. Okay, after that we are moving forwards the routing part. In the routing part we have to discuss about the basics of router and the routing protocols. The routing protocols. After that, we have to learn. After that, we have to learn how to take remote access of the router and the different services. Different services. Okay, how to take remote access for 1 minute. How to take remote access of the router and also how to configure different services over router over the router. Okay, then we are talking about the security purpose of this router, like how packets should filter over the router. That concept is known as the access control list. Access control list, which is the very most important topic, because this access control list is a very core structural model to filter the traffic. Okay, like this concept is also used over the firewall to filter the traffic. Okay, so that is the very important point. And third thing is about, sorry, the fourth thing is about the network address translations. Okay, like how to map a particular IP to another IP, like how to share our informations from LAN to WAN network or LAN to LAN network. That is should define or that particular work should done by the network address translation. So we will discuss it over our sessions. Okay. After that, we are continuing with also the switching. The switching part, and the switching part we also follow the basics of switch and the switching protocols as well. The switching protocols as well. Then we should follow uh, different different securities, uh, different securities criterias over the switch. And the last thing is about the layer 2 security, the layer 2, or which is also known as the port security. Security. Okay, so these are the basic structural models of your in-depth networking course. So we would follow step by step. Okay, so today we are going to start the topic about the OSI model. Okay, so before I start the session, I want to say something about this OSI model and the TCP/IP model. Okay, so the OSI model, we actually in this model or from today's class to some other classes like 1 to 3 classes more, we are continuing this OSI model and TCP/IP model both combined. Okay, why and how, that we'll discuss it when I try to explain both these models. Then okay, so let's start the session. So the first thing is about the OSI model. What is OSI model? The OSI model stands for Open System Interconnection. Okay, it stands for Open System Interconnection Model. Interconnection. Actually, OSI model was the first model which is introduced to give the basic idea how devices are connected with each other to form a specific network, and through this network how information should negotiated between them. Okay, but OSI model follows the very basic rules and regulations, and it can also explain all the things properly. But the main thing is that when in the case of implementation, if we try to implement the OSI model in the practical field, at that time OSI model became failed because due to some flaws, OSI model didn't implemented properly. Okay, so what are these flaws? So this flaws is like OSI model does not carry any protocol suite models. Like it can explain all the things properly, but how they should work properly or how they should implement it over the devices, that things on that point of view, OSI model completely failed to explain that things. Okay. After that, after OSI model, there is another agency. Actually, OSI is specially designed by the organization which is known as the ISO. ISO stands for International Organization for Standardization. It is an open organization company which is used to or which is define or which is standardize some specific services or some specific informations globally. Okay, so in ISO, through ISO in 1984, OSI model was invented. Okay, so after that there is the another model given by the DoD. DoD stands for the Department of Defense. That model is known as the TCP or IP model. TCP stands for the Transmission Control Protocol, whereas the IP stands for the Internet Protocol. This is the specific model which carries the first IP suite model. Like the flaws that carried by this OSI model should completely explained and completely used in the real field or the real devices scenario by using this TCP or IP model. Okay, so the TCP/IP model is known as the implemented model, whereas the OSI model stands for the reference model. We just follow both the models because through OSI model we can gain the keenful knowledge about the network, like how it is created and how it should managed properly. And through the TCP/IP model, we have to learn how the real thing should work. Okay, so that's why in the theoretical part or in the theoretical module, we should follow the OSI model, whereas in the part of practical scenario or the real field scenario, we have to follow the TCP/IP model. Okay, so what is the purpose of this model? OSI model and the TCP/IP model. What are the purposes about these models? How and why do you need these models? Actually, we connected multiple devices. There is a definition. So there is a definition of which is used to define the network. Actually, if you try to say network, what does it mean? Okay, so network simply means that like connection of multiple devices. If you connected more than one devices with each other, that particular things, that particular connection is known as the network. Okay, so if we connected multiple devices, then how this connection should created? Like what are the perspective and what are the rules that the devices should check and create that particular session. That particular information should given by the OSM. Second thing is about if we connected multiple devices, then the main thing is that to negotiate the main purpose to connecting them is to sharing the information or to sharing the resources between them. Okay, so if you consider that particular point, so how they should negotiate informations between them. If there is a problem or if they are facing some problems, then how to solve them. Okay, what are the solutions to resolve that problems. Okay, so that are the things that completely resolve or that things should how do I say like all these concepts should manage by this OSI model and TCP/IP model. Okay, it can give the brief model like how to connect the devices and how information should negotiate between the devices, and if they found some problems, then how to resolve it. Okay, all the things should managed by the OSI model on the TCP/IP model as well. Okay, that's why we have to read these specific models. Okay, so to doing these things, our OSI model is divided into 7 parts. The first part is the application. Actually, this is not the first part. Actually, this is known as the seventh layer. Okay. First, I write down the layers, and I should explain it. What is the layers and how how that particular layer should work. Okay. So application, presentation, session, transport, network, then data link, and now the physical. Okay, so this is the seventh layers. Actually, to doing all these things and to manage whole network properly, the OSI model is divided into these 7 layers. And here I wrote it in descending order. Like this is the seventh layer, whereas the presentation layer is the sixth layer, and session is the fifth layer, transport is the fourth, network is the third, and the data link is the second, and physical is the first layer. Okay, and I also told you that there is another model which is known as the implemented model named as TCP/IP model. Okay, after TCP/IP model, after OSI model, TCP/IP model was invented by the DoD, which is known as the Department of Defense, that particular organization, and that particular model can easily follow all the concepts of OSI model, and it also can easily implemented over the devices, because the TCP/IP model is the first model which is used to explain the whole protocol suite properly. That's why we've implemented the TCP/IP model over the devices to create the connection to share information or resources among them. Okay, so if you see, to doing these things, also the TCP/IP model is divided into some layers. What are these layers? So the layers is like 1 minute. Okay, so this layers is like applications. Second thing is about the transport, then the internet, then the link layer. So the first TCP/IP model is of 4 layers, where the application layer is the fourth layer, transport layer is the third layer, internet layer is the second layer, and the link layer is the first layer. Okay, what are they? Actually, if you compare this TCP/IP model to the OSI model, then you can see a very similar things. Like these 3 layers of OSI model is combinedly implemented over the TCP/IP model named as application layer. Okay, in TCP/IP model, the first layer, the fourth layer, application layer, should perform these 3 layers task in a single layers. Okay, if you can see in OSI model, the application, presentation, session, these three layers are doing the different types of works. Okay, whereas in TCP/IP model, both are combinedly doing all the things in one layer, which is known as the application layer. Okay, and the fourth layer of OSI model is the transport layer, and that particular layer is also remains same in the TCP/IP model. Third link, the third one is in OSI model. The third layer is about the network layer, whereas in transport layer, sorry, in TCP/IP model, the network layer is remains same, but there is slightly changed by its name, where the name is replaced by the internet. Here is a term that used to identify this network. That name is internet. Okay, and now this in OSI model, there are two specific layers. There is data link layer and physical layer, where the TCP/IP model both are combinedly implemented through one layer, which is known as the link layer. Okay, so the first TCP/IP model was like this. Like here we can see the four layers in this TCP/IP model. But nowadays, if you see the TCP/IP model, which is named as the updated TCP/IP model, which is guys, just give me a quick minute.
Mhm.
Hello, guys. Guys,
Hello.
actually, yeah, we have a new student here, Emmanuel.
Yes, sir.
Yeah, how are you?
Fine, fine, and you, sir?
Okay, fine. I'm absolutely fine. Thank you. So, Emmanuel, I think you were late today. Okay, so you just follow the recording sessions that I will forward it after the end of the session. Okay, so
Okay.
just stay muted. Whether there is any doubts, then you can unmute yourself and ask me. Okay,
Okay, sir.
so let's join the session and restart the session also. Okay,
Okay, okay, no problem, sir.
okay. Thank you.
Yeah.
Stay muted, Emmanuel. Okay. So, okay, so where is the topic? Okay, we're discussing about the updated TCP/IP model. Okay, so the updated TCP/IP model is very similar to its previous model, but there is a slightly change. The fourth thing is about, okay, here is the fourth layer. Fourth, sorry, the layer is like application, then the transport, then here the internet is again renamed as the network layer, and the link layer is again divided into data link and physical. Okay, so nowadays we are having the updated TCP/IP model. 1 minute. Okay, so which is having this, like this is the fourth layer. 1 minute. Okay. Second thing is about the third layer. The transport layer is the third layer. Network layer is the second layer. Data link layer is the, oh sorry. This is the fifth layer. Okay. Fifth layer, fourth layer, three layer. The physical layer is the first layer. Okay. Okay. So this is the updated TCP/IP model. Okay, guys. So this is the entire layers of OSI model as well as the TCP/IP model. So we should follow these two models where we are discussing about the OSI model like these 7 layers, and in TCP/IP model we are also discussing about these 5 models, these 5 layers. Okay, if you want to confirm these values, just search over the internet and you can get the best structural model over there, like OSI, OSI model, and the TCP/IP model. Okay, so now you can see this is the model that I already present in front of you. This is the OSI model having 7 layers. The TCP/IP original model was in 4th layer, having 4 layers, but now we are using the updated TCP/IP model where we can get 5 layers. Okay, so this is the basic layer concept about the OSI model and TCP/IP model. Okay, so let's start to explaining what is the purpose of these layers, of these individual layers, like what is the purpose of application layers, the presentation layers, session layers, and like this. Okay, so I again tell the same thing, like I should follow the theoretical model in through OSI model, and do the practical or explain the practical things that followed by this OSI, sorry, the TCP or IP model. Okay, that is known as the updated TCP/IP model. Fine. So here I give you some specific model structure or some specific PDF to read the theoretical part, or which is named as the OSI model. Okay, it is the one of the best PDF that I have ever get in my life. Okay, but the words are very simple and it is well explained. Okay, if you try to follow this PDF, then you also go through it. Okay, so the thing is like 1 minute. OSI by Router Ale. Here is the model. Okay, so I simply forward this link in the group. Okay, so guys, just copy this link. If someone need to read about the theoretical part or about the OSI model, you should go through this model. Sorry, you simply go through this PDF. It is very helpful. Okay, so let's start about the application layer. Okay, application layer. Okay, so the application layer is the 7th layer of OSI model, whereas the application layer of TCP/IP model is the 5th layer. In the operated TCP/IP model, the application layer is the 5th layer. Okay, but the purpose of this application layer remains same, because in OSI model, the things are done by the application layer, presentation layer, and the session layer. Both these tasks should combinedly performed in one layer, which is known as the application layer in TCP or IP model. Okay, so don't be confused to term like that application presentation system. Actually, these are the individual layers in OSI model, but in TCP IP model, it is that both 3 layers can combinedly execute that task in one layer, which is known as application layer. Okay, so I should literally want to describe the theoretical part first. So the main task of application layer is to define the user interface. Like the application layer is used to identify or to providing the user interface. Okay. So here is the term named as user interface. What does it mean? like user interface, there is an interface where a user can easily communicate with any device. Okay, that particular interface is known as the user interface, where if you can see, if okay, here I am using the Windows operating system. Okay, so after starting this window, after turn on my system, Windows takes some particular time, and after some time it will give me the screen which is known as the desktop screen. And after getting the screen, if I want to do some task over my system, then I can definitely do these things. Okay, so that particular screen, that particular desktop is known as the user interface, because that is the main thing by which I can easily interact with my device. Okay, so this user interface maybe is of two types. One is GUI, which is known as the graphical user interface, and the second one is the CLI, which is known as the command line interface. Okay, so it is not in the part of these things. Okay, it is just very basic things that I should think it is good to explain it here. That's why I explain it. Okay, it is not the main task of application layer. Okay, so the main task of application layer is to define the task through this graphical user interface. Like, I need the graphical, I need the user interface. What is the purpose of this what is the purpose to get the user interface? Because so the main purpose to get the user interface is to doing some things, like to do some work with over that particular device. Okay, so that things is like, if I want to do some work, like if I want to send a mail. Okay, if I want to play some game over my systems. Okay, so there is a sorry these are the specific examples of the work that done by me over my systems day by day. Okay, so to doing this particular things, uh, system should follow some specific protocols or some specific rules. Okay, according to OSI model, application layer, according to OSI model, the application layer is used to define these specific services. Okay, like if I want to share some file from one device to another, to doing these things, in OSI model, the application layer use a specific protocol or some specific rules, which is named as the FTP. Okay, and the second thing is that if I want to share some email, or if I want to do a email to a friend of mine, so that time we are using SMTP maybe. So, or you can see the POP3. Okay, if you take another example, like, okay, if I want to take the remote access of my device, then I can definitely use the telnet or use the SSH. Or if I want to access any web services, then at that time I have definitely used some HTTP or some HTTPS things. Okay, so these are the specific services or specific rules that we should follow if we try to do some task over the system. Like, when you are using the after getting the user interface, when we want to do some task as per the OSI model concept, this application layer is helping ourselves to providing these particular protocols by which we can able to do this task. Okay, whereas the TCP/IP model exactly explains the same, but here is the little bit change. Like in TCP/IP model, that particular model rectify that particular things. Like, these are not the protocols; these are the services which are used to execute the whole process. Okay, it is not like, if I try to do a task like, okay, if you can see, if I want to do a image, if I want to draw an image here. Okay, so I choose lot of tools available in this home tab. Okay, different shapes, different colors on the, if I try to put some colors, like some clear type colors, or process. So there are various types of callers. Okay, so by using these specifications, if I draw a image, okay, so the main thing, the main task is to draw an image. But using these tools, that thing should properly done by me. So these are the specific services. These are not the specific protocols by which we should do the things. Okay. Actually, that things is very similar because that particular services should manage by the rules. Okay. That thing should explain by the OSM. Okay. But in TCP/IP model says the same things like these are the services. Okay, and the application layer of TCP/IP model is used to identify or to define that particular services. Okay, like if you can see, today we are using the devices which are multitasking in nature. Multitasking means in a particular time our system can able to do more than one task. Okay, more than one task. So if you can see to doing a single task, if our system needs some multiple services, then if it is multitasking tab, it can definitely be able to do more than one task, and to doing this more than one task they are using a lot of services. Okay, so to manage this particular services in TCP/IP model, these services should arranged should arranged or should bind with a logical numbers. Like for FTP we are using a number which is named as the 20 and 21, and you can see for telnet the number is 23, for SSH the number is 22, for POP3 it is 110, for SMTP it is 25, for HTTP it is 8, HTTPS it is 443. So these are the logical numbers which is used to identify some specific services. Okay, so that particular numbers which are used to identify or to define the specific services, that particular numbers, these numbers are known as port numbers. Okay, so port numbers. So what is the proper definition of port numbers? So I can write it here. What is port numbers? Okay, the logical numbers, the logical numbers which are used to define or used to specify a service. The logical numbers which are used to specify services services are known as port numbers. Okay, so this is the main concept. Like in TCP/IP model, all the services should managed in a particular manner, and that manner is named as port numbers. Okay, and this port number is of 16 bits. Okay, so I also write the same thing. It is of 16 bits. If you can see it is 16 bits, if you describe it in decimal, so the range is belonging from 2 to the power 16 to raised to the power 16, and which is equals to 65536. Okay, so in this binary number system, the calculation process should start by 0, and the range is from 0 to 65535. Okay, 0 is reserved for the self, like devices use this 0 to 0 for itself, like to identify the specific services easily. Okay, and the specific range is from 1 to 65535. Okay, and that particular range is divided into two types. Okay, so I simply draw this diagram where is you can get the proper idea about the port numbers. So port numbers is about 1 to 65535. Actually, this is the specific range which are used to that particular range is used to identify the port numbers. Okay, and that particular port numbers range is divided into two parts. First one is the well-known port number range, the well-known port numbers range, which are 1 to 1023. Like in this range, like 1 to 1023, if you choose any number, if you choose any number within this range from 1 to 1023, then you can get a specific service bind with that particular number. Like if you choose 40, sorry, if you choose 80, then there is a service which is named as HTTP. If you choose 23, then there is a service which is used to take the remote access named as Telnet. So if you choose any number within this range, you can definitely get a specific service bind with that particular number. That's why it is named as the well-known port numbers. Okay. Okay. So 1 minute. I think my handwriting is not well. I have to write it clearly. Well-known port numbers. The range is from 1 to 1023. Okay, so the second thing is about the range from, it is named as the dynamic port range, dynamic port range, dynamic port number, dynamic port numbers, okay, which is again divided into two types, divided into two parts, where the first part is known as the registered port number, the registered port numbers. The range is from 10242 49151. And second part is used for uh, the private port numbers. The okay, 1 minute, sorry. Port numbers. The range is from 491522 65535. Okay, so this is the classification of the port numbers according to the use, according to the uses. Okay, so let try to explain it. What is the need to define the port numbers? Try to define the services by using these logical numbers. And what are the main concept to put the port numbers into this scenario? Okay, so let's start discussing about it. Like if you see, I have a server. Okay, 1 minute. Okay, so you can see here is a server, and I love to watch the cartoon movies. Okay, so one of them is available over this server. Okay, and I need to watch it now. So to doing these things, I have to download the movies through this server to my system. Then I'm able to watch that particular movie. Okay. So to doing these things, I use a specific service named as Telnet. That means I take the remote access of this server, and after that, I can able to download this particular movie from server to my system, and then after I will able to watch this movie. Okay. So to doing these things, I first generate a request to towards the server, okay, where I have to define what is the service or which type of service that I requested through the server. Okay, so to doing these things, I put a destination field which is used to define the services, and here you can see I am simply define the number 23. Okay, so here is the questions like, if I try to if I try to gain some specific services access, then I definitely use that specific service name also. Like instead of 23, if I tried telnet, Then server check the telnet, and if the particular service is available over the system, then it can definitely provided me. Okay, so what is the purpose to implement in 23 instead of telnet? Just you can see one thing. If I write telnet, okay, and we also all know, like our systems understanding only one language, which is known as the binary language. Okay, so if you take the telnet as a character value, then the telnet is of 6 words. So our system first converted these character values into decimal values by using the ASCII code. Okay. After that, now my system should get 6 decimal values, and now it again converted these decimal values into binary form to understand that what is the actual request, what is the actual purpose of this specific request. Okay, so to do these things, you can see our system should follow two process, and the conversion process is extremely lengthy. And when it again try to reply me, when it trying to reply me, then it also doing the same things, which is also a very lengthy process. So if I use the direct name to identify to identify the specific service, then the negotiation of information uh, the negotiation of information is going slower, because every time it's simply used to identify, say, every time it is use this process to identify what is the purpose of this connection. That's why it taking some time, and by this the whole process is getting slower. Okay, but you can see if I using 23 instead of telnet, then server receive the port number which is 23, and again 23 they convert it into binary form. To convert 23 into binary form, it is a very fast process for system, because if you can see, if I try to explain it, okay, so I can definitely use like this 11101. So this is the binary form of 23. Okay, so for me it is less than 2 seconds of a systems which is literally have that much of ability to process or to compute this logical values, then that process is a very rapid, or it is executed a fraction of seconds, a fraction of milliseconds, less than 1 seconds. Okay, so the so it can simply convert this 23 into binary form, and it can able to understand what is the purpose of this particular request. Okay, you just check the library and you can know that 23 is a number which is used to identify, or 23 is used to specify a specific service named as telnet. Okay, so you can see that there is a PC which is trying to make or requesting for a telnet service to me. Then it simply understands these things, and it simply, if that specific service is available over this server, then it simply reply back to me to give the access of this remote connection, and now I'm able to download that particular movie to my system, and now after getting the movie I am able to see the movie. Okay, so this is the main purpose to don't use the whole name, actually this is the main purpose to use logical number, so the logical name instead of the whole name, to identify or to specify the specific service. Okay, so guys, till now everything is understandable, or there is some doubts in your mind? Hello, guys, am I audible?
Yes, yeah.
Yeah, everything is clear, or there is some doubts?
Yeah, it's clear, but I didn't get to about the telnet part little bit.
Oh,
But
talent bat. Actually,
yeah.
talent is a character. It is a word that formed combination of
Okay.
characters. Okay.
Okay.
So if you requested the specific service by using this talent, which is a word, then to understand that specific word, what is the purpose of this word talent. So the system follow this specific conversion process. Like it simply follow the ASCII code to identify what is the decimal values of this telnet character. It choose for system the telnet is simply the characters, which is mean that TELNET. Okay,
Okay.
this is the
Okay.
six
Got it.
characters which is
Yeah.
used to used to define something. Okay, so it
Okay. Okay.
simply convert that values into binary and again convert it to the decimal form, sorry, into the binary form to understand what is the purpose of this word telnet. Okay,
Okay. Okay.
so to
Got it.
converting process is a very lengthy process. That's why we are using the code number instead of the whole name.
Okay.
Is it
Okay.
clear
Got it.
now?
Yes. Yes. Yeah. I got
Okay.
it.
Okay, thank you.
Yeah. Thank you very much.
So guys, just give me some quick minutes. Okay, I have to go to washroom. Actually, I get a lecture calling. Okay, 1 minute just. Okay, sorry guys. Let's start the session again. Okay, the recording is on. It's fine. Okay, so this is the main purpose to define. Okay, so this is the main purpose to implementing the port numbers instead of using the whole name to identify the specific service. Okay, so now we have to see what is the main task to perform by the application here. Okay, so again reuse the same example. Okay, so let's see. uh, Here is the server. Okay, here is the server. Okay, here is the PCA, and here is the PC named as PCB. Here is the PC named as PCC. Okay. Uh, okay. So you can see PCA wants to download some information or wants to download. Sorry, this PCA wants to download some movies to this particular server. Okay, to doing these things, if PCA send a request, send a telnet request to the server. Okay, so the destination number is, so the destination port number is 23. Okay, so if the specifics request received by the specific server, then server immediately make an entry. Okay, like this. Destination port number is 23. Okay, and the specific purpose is the movie. Just take an example. Okay, for understandable purpose. Okay, actually this is not the actual model. Okay, it is just used it is just I explaining to understanding all the concepts, all the processes should done by the application layer. Okay, okay. If you can see at the same time when PCA requested for the telnet request or the telnet access of the server, at the same time PCB also wants to listening to the music. Okay, at the same time PCB wants to listen some music from the server and is again doing the same request to the server, like it is also requesting for the telnet to download some music and listen that. So to doing these things, server again receive the port number 23, purpose song. Okay, if you can see it is a PCC again, it is also requesting for the same service which is named as 23, and the purpose is to do a email. Okay, so you can see in this server, the server is receiving 3 requests. Okay, where all the destination port number is totally same. Okay, so when okay, these things is not that much of confusing for the server, but the main thing is that when the server is starting replying, when the particular server is starting reply to this specific request, then the server will be confused. Why? Because the port numbers are remain same. The request port numbers over the server is remain same, but the purpose is different. So the server is getting little bit confused for which PC sends which service request. Okay, so to get or to deliver all the things, all the requests properly, create this table by arranging in this way. Like here is 3 fields. One is the destination port field, which is remain the same, and here is the another field which is known as the source port numbers. Like if the PCA requested for telnet, that it is also using a source port number to unique identify itself. It is the range or it is the number which is randomly taken by any device through this particular range, which is known as the dynamic port number range, which is from 1024 to 65535. Okay, so you can see that so you can consider like this port, now this PCA may choose 1024 for its unique identification or as its source port number, like this is the 1024 port number. Okay, so if PCB requested for telnet by taking the source port number as 1024, then when server started creating the table and you can see it is the 24, then it simply check that this 24, this source port number value is already exist in this particular table. So it simply discard this packet, simply discard this specific request and send a message to this particular system, like it simply send a message to PCB, like you just modify some configurations in between this packet and try to resend this connection to me. Okay, so at that time the PCB modified its source port number as different port number and again requested to the server. And servers check that the port number is 1025, which is not available over this tabulation process, or this so that particular port number is not available in its own table. That's why it's simply recorded as 223, and the source port number is 1025. And for PCC, if the PCC using 1024 or 1025, it simply discard the packet. And here PCB use some different values to unique identify itself. Like it can be used 1026. Now, at the time of reply, the server doesn't get confused because now it has some specific port numbers which are used to unique identify a particular system. Okay, so that thing should managed by the application layer. In TCP/IP model, application layer is used to identify or to providing or to unify the specific services. Okay, so that is the main things which is done by the application layer in transport. Okay, so guys, till now any doubts? Hello, hello guys, hello
Yes, hello, sir.
guys, am I audible?
Yes, sir.
Yeah, sorry guys, do you have any doubts till now?
No, it is well explained according to me.
Yes, yes, Emmanuel.
I'm saying that it is well explained according to me, so no doubt for now, no question.
Okay, thank you very much.
Okay.
Okay, so any other guys have some doubts?
No.
Adamo,
It's okay.
Joyce, Srikant, it's okay, fine.
Yeah.
Joyce, Srikant, okay. So let's continue. Uh, 1 minute. Okay, so this is the main things of the application layer, the use of application layer. Okay, so we are moving towards the its next layer. Okay, guys, just give me a quick minutes. I'm getting a call now. Okay.
Hello. Hello. Hello.
Sorry guys, let's start the session. Okay, so now we are moving towards the presentation layer, which is we are taking this presentation layer concepts in our OSI model. But in TCP/IP model, there is a single layer application layer which is defined the presentation layer task in this particular in this same layer. Okay, so let's start the session. Okay, so the second layer is the presentation layer. Okay, so what is presentation layer? And the presentation layer is used to specify used to specify the format of over the I can see how to explain it in a very simple way. So okay, so you can see presentation layer is basically used to present something in front of the user. Like if I want to watch the movie, okay, so movie is a data, okay, so that data should accessed by the application layer. But when if I requested to watch that specific movie, then application layer transferred that particular movie to the presentation layer, because in presentation layer identify that the purpose of the data, like presentation layer specify the data, which type of data is that, is the movie, it is the mp4, or it is the song, it is the text file, or what else. Okay, so for presentation layer it is used to specify the specific format over the data. Okay, and now by implementing the specific format over this data, then it simply present that data in front of the user. Okay, so to doing these things, that's why the name is used to identify this layer is presentation layer. Okay, so the main task is to specify the formats for the data. Okay, which is the very major task for which is the very major task performed by the presentation layer. Okay, so you can see the data type. If it is a text, then if it is a text data, then the format is .txt. If it is image, then the format is JPG, maybe it's JPG, like this. If it is a movie, then the format may be MP4, 3GP, 3GP, like this. Okay, or SD high definition, like this. Okay, so this is the specific format which is used by the presentation layer to specify uh, the data. Like, what is the purpose of this data? It is the text data, it is the image data, or anything else. Okay. After that, beyond these things, presentation layer is also doing three major tasks. Okay. So these are the encapsulation and the decapsulation. Second thing is about the encryption and data decryption. Okay. Third thing is about the compression and the decompression. Okay. So these are the three major tasks performed by this presentation there. Okay. But here we don't discuss it now. Okay. So we are discussing these three concepts after the completing of this OSI model in the TCP/IP model. Okay, because the concepts that managed by these three processes that contain all the 7 layers informations. That's why we are discussing it after the end of this session. Okay, so just continue with the session. Okay, after that we are going to discussing about the another layer which is known as the session layer. Sorry. session layer. Okay, so session. So it is used to create, maintained, and terminated the session. Okay, actually session layer is used to create, maintain, and terminate the session. Okay, uh, like you can see, I'm taking your batch. Okay, so to taking your batch, there is just predefined time period, which is 3 to 6. Okay, so that specific time which is used to define your class time, that is known as the session time, which means that I am able to take the session within that specific time period. Okay, if I try to take more than of it, then I have to create a new session time and start the batch. Okay, so session, like over the system, if I try to do some task, for every task there is a predefined time is used or to define for to doing this task by the system. Like if I trying to okay, you can see, you can definitely see, take an example like this. If you try to pay a payment for your online purchasing, then you can see there is a predefined session time is coming out, which simply means that if you want to create this payment successfully, then you have to pay the specific amount within this time period. Okay, so that things is completely defined by the session layer. Okay, so the session layer is used to create, maintain, and terminate the session. Okay, second thing is about somehow somehow it is also trying to retrieve the session as well, retrieve the session as well. Okay, like you can see, uh, if you are talking over the phone with your friend or someone else. Okay, if the signal strength is extremely very good, then your communication is running smoothly. Okay, if your signal will be the strength of the signal strength will become weak, then you can see, like if you working when you are talking over the call and you go that particular place where the signal strength is become weak, at that time you can realize that there is no signal to make a call. Then you can immediately replace yourself from that place to the strong signaling place. After that time you can see the exact phone call over that in the weak field, you can't able to hear your other side voice. But when you uh, replace yourself with in this strong signaling place, then you can definitely get the voice back to your other side. Okay, so you can see that is the very technical example of this session there. Like it is also used to, or it is also trying to retrieve the session in some other cases. If the signal or the connection type is getting weaker, then at that time the session layer is also used to maintain or to retrieve the session as well. Okay. Okay, so in this session layer, or within this session period, the devices should share information with each other. That is known as the session communication. And the session communication is of three types. Okay, one is the full duplex. Second one is the half duplex. Third one is the simplex. Okay, what is full duplex? Full duplex is known as both-sided communication both-sided communication should done. Both-sided communication is possible. Communications. The communication is possible. Possible. Both-sided communication is possible simultaneously. Okay, like both the devices can able to share information in the same time. That is known as the simultaneously process. Okay, in half duplex, in half duplex, both-sided communication is possible. Both-sided communication is possible, but not simultaneously. But not simultaneously. Like there is the connection, there is the communication between the devices should done both-sided because both-sided, but not simultaneously. Which means that the devices able to share informations one after another. Just like if you can see, take an example of walkie-talkie. Okay, both-sided communication is possible, but not in simultaneous way. One devices if one devices share the information, then other side able to hear that information or receiving that able to receive that information. After the completing of this A side information, then the B side starting to share information to the A side, and at that time if A start saying something to PT with to the other side PC or the other side B, then both the devices can able to hear the things. Okay, so the have to play is the communication type where one devices can share informations after another. Like one devices after completing one device information, then the next device start sharing their informations. Okay, and but if you start comparing this half duplex with the full duplex communication, then you can see it is the best example like our live sessions. Now I am able to share information with you, but someone between you, if try to share something, then definitely I am able to hear it. Okay, the another way over our phone, over our telephone. Okay, like if I make a call with my friend, and when I say something to my friend, then at that time he should speak, then I am definitely able to hear that voice. Okay, so in full duplex, both-sided communication is possible simultaneously, but in half duplex, both-sided communication is possible, but one after another way, not in simultaneously manner. Okay, and the third thing is about the simplex, which is known as the one-sided communication. The one-sided communication. Okay, like if you watching the YouTube, okay, so this that things is the best example of simplex. Like there is the only one source information is there. Like your YouTube, you can get the information. If you want to say something to YouTube, then you don't have that ability to share the informations in YouTube. Okay, it is the best example of simplex communication. Okay, so it is the session communication, like the communication type. Okay, here is the another part which is known as the mode of communication. So the mode of communication is also of three types. Okay, so the mode of communication is also of three types, which is which are known as broadcasting or broadcast, multicast, and the last one is the unicast. Okay, so what are they? Broadcast, like if you see, I take an example, like I just take an example like okay, here is a school. I take the example of 10th standard. In a school, there are three sections in 10th standard, like A, B, and C. Here is the principal of the school. Okay, the principal now announce some specific informations with the students. that belonging from all these sessions, all these three sections. Okay, like the informations is shared between A, B, and C both. Like broadcast is one to all. Like if I try to share information between everybody that present in that particular area, that communication is known as the broadcast communication. That mode of communication is known as the broadcast communication. Okay. The second thing is about the multicast. What is the multicast? Multicast means that one to many communication. One to many communication. Like this is the broadcast. This is the example of broadcast. Broadcast. Like the principal shares the information among all the students of these three sections. But if you see here is the three sections again A, B, C. But the principal share the informations only the section A. Like principal share the information with the students. They are belonging from section A. They belongs to from sorry. They belong from section A. Like there is a group. There is a group of students of section A should receive the information, and sorry, the principal only able to share the information through this particular section. Okay, so that type of communication is known as the one to many communication, and that communication type is known as the multicast communication. Okay, and last one is the unicast, where the communication is one-to-one communication. Like among these three sections, principal, principal call a student and talk with him directly. Okay, that is known as the unicast communication. Okay, so these are the mode of communications. Okay, so this is the all about our application, presentation, and session. These are the individual interactions or the individual purpose of these three layers in OSI model, and these three things should combinedly performed in one layer in TCP/IP model, which is known as the application layer. Okay, so actually, guys, this the application layer of TCP/IP model, or in OSI model, the application presented as the session layer. These three is in OSI model is also used in software cases. Like the most important part of the most of the functions of these three layers of OSI model is used for software cases. So there, so these are some specific concepts that we are able to need or we are need to know for our cyber security perspective. Okay, so these are the basic concepts. Okay, so guys, is there any doubts? Hello, guys, is there any doubts?
No, no, no.
Nothing. Okay, fine. Okay, fine, thank you. Okay. Mhm. Okay, so now you can see. Okay, oh, I have to explain something. Okay, okay, so you can see these three layers of OSI model, and the first layer of TCP/IP model is used for software. Okay, and the remaining three layers, transport network data link, and also the transport network data link. These are the core concept. So these are the layers which are used to sharing informations, or which are used to define or responsible to sharing the information over the device. Okay, so we have to penetrate as much as we can about these three layers, because all the concepts of networking or our cyber security perspective, all the things should carried by these three layers. Okay. And the last one is the physical layer, which is used for the physical connectivity of the device, which is mostly used for hardware concepts. So this is not actually that layer that much. Actually, that layer is not that much relevant to ourselves. So we have to know. We have to just read what is the purpose of the physical layer. That's it. But we have to read carefully about these three layers, which are the transport network and data link, were in OSI model and the TCP/IP model as well. Okay, so let's start about the transport layer. Okay, so transport layer is today's last topic. Okay, so after that, we are for tomorrow we are starting the next topic is about network layer. Okay, so now the last topic is about the transport layer. Okay, transport layer. Okay, so the transport layer is used to transport layer is used to create a reliable connection. A reliable connection. Okay, the transport layer is used to create a reliable connection between the devices. Between the devices. Okay, like if I discussing about the transport layer, both in OSI model and TCP/IP model, the purpose of transport layer is to create the reliable or the trustworthy connection between the devices. Okay, what is the reliable means that, like if the devices using the transport layer to share the information between them, then the connection type between the devices is trustworthy. Okay, so to doing these things in OSI model, they are using two types of protocols, which is known as the oriented protocol, connection oriented protocol, and the second thing is about the connectionless protocol, the connectionless protocol. Okay, but in okay, so what is connection oriented protocol? Like if the devices are using this connection oriented protocol to sharing information between them, then before sharing some data, they are definitely use a trustworthy connection between them. Okay. If you see the devices are using the connection less protocol to share the information between them, then for the connection less, they literally don't they literally don't have check or to create any reliable connection between them. Okay, so instead you can see the safe connectivity is performed by the oriented protocol, the connection oriented protocol, and the less secure connection or the less connectivity between the devices should performed by the connectionless protocol. Okay, so we are discussing more about it. So let's discussing about the another things. So in TCP/IP model, there is also two specific protocols which are used to specify the exactly the same kind of things that performed by the connection oriented protocol and the connectionless protocol. So the first one is about the TCP. TCP stands for the transmission control protocol, and the another one is the UDP, which stands for the user datagram protocol. Actually, these are the specific protocols in TCP/IP model, which is very similar to the the OSI model protocols. Like the TCP is named as the connection oriented protocol, because if the devices are using TCP to share the information between them, then they should definitely before started sharing the informations, they are definitely create a very reliable connection between them. Okay, but when the devices are using the UDP, which is known as the connection less protocol, that means if they are using UDP to sharing the information between them, then before sharing the data, they literally don't create any reliable connectivity between them. They simply share the data whether they are connected or not. They literally don't check the connectivity between them is reliable or not. Is it trustworthy or not? It simply relay the data. Okay. So what are these types and what are the things that let discuss about it. Okay. So first thing is about the connection oriented protocol, or in TCP/IP model, it is the transmission current protocol. Okay. So you can see the connection oriented protocol. That means I already told you that if the device is using the connection oriented protocol to share the data between them, then doing these things, they first create a reliable connection between them. Okay, so to create the reliable connection, they should follow some specific services. They are using some specific services to create a reliable connection between them. So what are these services? That these services are services followed by connection connection oriented protocol, or इसको आप you can also consider it for the TCP as well. Okay. Okay. Here the connection oriented protocol definitely doing some services. That services are mainly divided into four types. Okay. That specific services are divided into four types. Okay. Then what are they? What are these? The first thing is about the segmentation process and the sequencing process. This is the first process done by the device. Sorry, done by the devices. Second thing is about the connection oriented, or sorry. The second step is about the connection establishment, establishment. Third thing is about the acknowledgement, and fourth thing is about the reliability, or the reliable. Sorry. Fourth thing is about the flow control. Okay, so these are the specific services followed by the connection oriented protocol to make or to create a reliable connection. Okay, so actually the main thing is that the reliable means that the acknowledgement. Okay, like if you can see. Okay, so just take an example. I have two persons. Okay, like I want to transfer. I have to pay some money to a guy. Okay, and I choose a student named as A and give some money and tell him to give that money to this another guy. Okay, A should do these things, and after completing, or after give the money to this person, then they're continuing their another job. Also, they're simply moving another side. Okay, then after I'm choosing another student which is named as B, and I simply give some money to PCB and and tell him to transfer that money to this person. The student B will move to this guy, transfer the money, and after give him the money, he just coming back to me and replying me like I'm successfully gave the money to that particular person. Okay, so if you consider these both examples, you can see the most trustworthy work is done by the PCB, where the PCA also doing the same things. But if someone asks me who is the trustworthy person, then I definitely say the PCB, because the PCB acknowledged me. Like PCB gave me the surety that he successfully done that particular task. Whereas PCA also doing the same thing, but he doesn't acknowledge me. Like I'm still waiting for PCB, like whether it he gave the money or not. Okay, so that things, like the acknowledgement is the very most important service or the specific task should performed by the connection oriented protocol to make the connectivity between the devices is reliable. Okay, so let be discussing the different services one by one. Okay, 1 minute. Okay, so first process is about the segmentation and the sequencing. Okay, what is the first process? Let's start discussing it. Like here is the PCA and here is the another PC named as PCB. Okay, so I simply connected them with a cable. Okay, so in PCA has 2 GB of data and wants to share this 2 GB of data to this PCB. Okay, so let's assuming that if PCA send this whole data at a time to PCB. Okay, just let's assuming that. Okay, so what so you can see, to process this amount of data, that amount is literally a huge amount. Okay, so to process this huge amount of data, the CPU utilization of PCA is extremely high. And also when the data is traveling through this particular cable, then the path is totally consuming by this whole data. If PCB wants to share some data with PCB, then definitely they don't have the specific space to carry so like that particular medium doesn't have specific space to carry or to negotiate the information from PCB to PCA, because the PCA uses all links capability to share this huge amount of data. But at the end, like when the data is traveling through this cable, at that same time, PCBA lost its internet connectivity or lost its power supply to this system. At that time, the data traveled by this link is totally lost. To doing this whole process is getting useless. Okay, and you can see if I simply send the whole data without saving it within this PCA, then also I lost the whole data at same time as well. Okay, so to solving this type of problems, like if I send the whole data, there is definitely a risk. If there is any problem or any hazard is occurring on this over this connectivity or like over this medium or over the devices, then there will definitely be a chance to lose the whole data. Okay, so to resolving these things, before sending this huge amount of data, PCA simply divided the whole data into smaller pieces. Why? Actually, here is a concept like over all the physical interfaces. Like you can see, if your system has some specific ports to negotiate the informations, then you can definitely show that. You can see here is the command. Just a minute. Google. Okay. How to check MQ size in Windows. Just give me a moment. Just give me a quick moment. Okay. it is the command. Okay, what is the command and what is the things that I want to explain it is that, okay, like you can see, 1 minute, is there any issues? Okay, is there something I left? Like, that is this. Net SSH interface IPv4 set sub interface. 1 minute. Okay, sub interface. So I have to paste this whole thing. Mhm. This is the post command. Okay, so guys, see, actually here is the concept which is known as, okay, here is the concept named as MTU. You can see here is the Wi-Fi. That means it is the wireless interface by which I can able to share any informations to another system through that particular platform. Okay, like I can able to outsourcing the information to my system to another system by using this Wi-Fi. Okay, at the same time you can consider that there is the Ethernet type, which is also a physical connectivity medium, which is also used to uh, negotiate or sharing the data to another system, or to a sorry, to my system as well. Okay, like these are the specific ports which are used to share the data or outsourcing the data in between my system. Okay, so at that time there is a concept like both these interfaces having the equal size of MTU. One is 1500 and the Ethernet as well as the 1500. Actually, MTU stands for the maximum transmission unit, which is defined that all the possibilities ports, all the availability ports over a system which are used to negotiate the informations between other devices, then these devices should share the information like what is the amount of data that the particular device should able to share in a single time. That specific data is named as MTU, maximum transmission unit. Like that is the specific amount which is 1500, and this size is universal like 1500 byte. It is the data size which is known as the MTU. That means that all over the world, any device wants to share the data to another system, then at the time of outsourcing the data, the outsourcing, like it will be able to maximum, sorry, that particular system should able to share maximum up to 1500 byte data in a particular time. If you want to more than a bit, then it is not possible. Okay, by which you can see what is the purpose of this MTU. Like if I want to share the 2 zip data from PCA to PCB, then the concept of MTU, by the concept of this MTU, the interface is able to share the data in a particular time is 1500 byte, but the data is the available data is 2 GB. So to share the data between PCA to PCB, then the PCA, if the PCA using the reliable connection or the TCP protocol, okay, to sharing the data between A and B, then it simply follow the segmentation process. The segmentation process is that comparing the MTU size, it is simply divided the data into smaller pieces. Okay, it is simply divided the data into smaller pieces. That division process is known as the segmentation process, and after this segmentation process, the smaller pieces of data that we get, that is known as the segment. Okay, And now you can see if we are the PCA and PCB using the reliable protocol to sharing the information, then PCA just share the first segment to PCB. Okay, after getting the segment from PCA, PCB send an acknowledgement to PCA. After that, PCA send the another segment of data to PCB. Okay, that things confirm that the connection between A and B is reliable. Like if in case the first segment is lost, then the PCA doesn't send the another segment of data towards PCB. Like my data loss, the risk of data loss is minimum if we are using the reliable connection between, sorry, if we are using the reliable protocol to sharing the data between the devices. That is the main purpose to implementing the MTU over the interfaces. And second thing is that actually there is another issue like uh, this data, like if I have the data, like I read a book. Okay, after dividing the data, I simply send the randomized segment or the data in a segment through the another side. So when the PCB rearrange the data, maybe they rearrange the data like a book, sir, I book read a. Maybe because without any identification, if PCA is sharing the data PCB, then there is no identification over the data, then PCB arrange it in their own side. Like whenever PCB receive the data, it simply arrange it in a no sequential manner. Okay, that maybe give us a risk like the data I want to share from PCA to PCB, and after receiving all the data from PCA, the PCB shows the whole data in front of me. Maybe that information, not the same informations that available in PCA. Okay, so to confirm that, it is you also using a unique identification process which is known as the sequencing process. Okay, after the segmentation process, it's simply using the logical numbers to identify the segments. Like it simply put the logical number over this segmented data. Okay. So if the PCB receive a segment numbered as 5, then the PCB surely understand that there is the remaining 4 segments are still weighted. Like the segment 1 to 4 is not received yet. So put this segment 5 to give some space for this one to for this segment 1 to segment 4. Okay, so that is the main thing is that after doing the sequencing process, the device can easily identify the data in a sequential order and arrange the data in this sequential order. And after arranging the data, if I compare the PCA data and PCB data, then the data remain the same. Okay, so this is the very most important service or the process done by the reliable connection to make or to share or to confirm the data negotiated between the devices, or over the data negotiated between the devices are remain same. Okay, there will not be any changes occurred during the data sharing process. Okay, so guys, for today's session from till now, is there any doubts for anyone else, guys? Hello, guys, is there any doubts?
No, it's okay. It's okay, sir. For
Okay,
me.
fine. Okay, thank you. Also, for today's session, I want to stop the session now. Okay, from here, and for tomorrow, I will start discussing about the connection establishment and the acknowledgement and the flow control concept. Okay.
Okay.
So I hope you guys enjoy the session, and thank you to attending the session with me. Okay, guys. Bye. Yes.
In this, is this comes under that networking part or another this?
Actually, these concepts of networking are mostly benefit. Actually, like the concepts that you read here,
Yes.
that is totally useful for your cybersecurity courses. Like for cybersecurity, you are doing all the things like the by using the TCP or UDP or IP protocol, the ARP protocol, the ICMP protocol. So these things that you read there. So before you read these things, you have to clear all the concepts. What is the TCP? What is the UDP? What are they?
It's,
So
okay, it's a
these
basic
things should
part.
managed by the TCP. Yes. That's why we are discussing all the things clearly in networking part. Okay.
And in the networking part, we'll go in a deeper view of this.
Yes. Sorry, router can able to share information between both the networks. Okay. So now the today's topic is about what else if I choose individual routers for individual LAN network, then how should they communicate with each other? Okay. So you can see I simply choose different routers for different LAN network. 1 minute. Like this. Okay. So I simply did the configurations. I simply do the configurations like for this. Here is the so here we need another network like 10.0.0.0/8 configure to do the configurations in between the network between this router, like the cable which is used to connect both the routers. Then we definitely need a LAN network to configure the that particular interfaces of this particular cable. Okay, so as for the concept, I simply did the configuration, so just check it carefully. Okay, enable config terminal interface functional 0 by 0. Then I choose a network one night, sorry, then I choose an IP like this, and this IP address is used as default gateway over this LAN devices that I already told you yesterday. Okay, so like 192.168.1.10. For this, it's also I need to configure the default gateway like this. Okay. Apart from that, I have to configure one IP address here. Interface fast ethernet 0 by 1. IP address 192.168.2.10. Okay, no shutdown. And this IP address is also used as default gateway in between these LAN devices. Over this LAN devices like this. Okay. So then after you have to configure two IP address by using this LAN, sorry, using this specific network 10.0.0 over these interfaces that connected via cable and also connected both the routers. Okay, to form a network. So you have to configure two IP addresses over these interfaces also. So the interfaces are interface faster than 0 by 1 IP address 10.0.0.1 to 5.0.0.0.0 and press no shutdown. Exactly similar that you already did over its another interface. Interface faster than 0 by 0. Then IP address 10.0.0.2 to 5.0. Okay, no shutdown. Okay, so now you can see all the interfaces should configure properly, and now they are all ready to share or to negotiate information between them. Okay, but you can see, if I started sharing some information from PC0 to PC3 like this, it will show it is not possible to sharing or to communicating to this particular IP address. It can simply text me like the destination host is unreachable. So where is the error? To mitigate this, we have to choose. I'm simply using the simulation mode. You can easily understand what is the actual point, where is the point that particular packet is dropped. So auto change the, if I press that particular information, then you can see it is ICP packet, and you simply forwarded the packet. Then the packet is dropped just over its router. So what is the reason of it? You can see I also told that router forward the packets on the behalf of its routing table. Okay, so after successfully done the IP addressing process, there's just 1 minute. Simply okay. So just after doing, just after done this IP addressing properly over its interface, then you can see this first router should prepare its routing table like 10.0.0.0/8 over its interface faster than 0 by 1. And the second network is 192.168.1.0 over its 24 over its another interface 0 by 0. And similar like this router 2 also doing the same like 10.0.0.0/8 over its interface 0 by 0, and second one is 192.168.2.0/24. It's another interface 0 by 1. Okay, so like you can see, okay, like you can see, so as per this routing table, if you want to share information from this LAN to this LAN, then over this router 1, this router doesn't have the network information of 192.168.2.0. It simply means that this router doesn't have this network information. That's why this router is not able to share information to this network. And similarly, you can see over this router 2, it is also not have the information of, it also not has the information of 192.168.1.0. Okay, so how the router should able to share informations without available that particular network information in its routing table? It is totally impossible. Okay, that's why router simply drop the packets here. Okay, because it doesn't have it doesn't have the destination network information in its routing table. Okay, so we have to add this destination network information in its routing table. Okay, so before doing this process, I have to I need to explain something like as for the IP address, like you can see, it is implemented the routing table which is having network and 192.168.1.0. Okay, I simply change its host name as router 1 like R1. Okay, that's why we can easily identify the network, identify the router. Okay, just R2. Okay, so and you also check the IP table over this router 2. Like you can see, there is the two network 10 and 192.168.2.0. Okay, so if you need to share information from 1.0 to 2.0, still that we have the configurations. Over this configuration, to doing this thing is completely impossible. Okay, so here is an option that we have to do over this router. That particular process is followed by the router. They can able to share informations between these different networks. That particular process is named as routing. So routing is a process by which devices can able to find the path from source to destination. And by using this particular path, they can also be able to share information with each other. Okay. So this routing process it is divided into two types. One is the static, and another one is the dynamic. Okay. What about static? Static is the process. Like what is static routing? The static routing is a process by which administrator can define the path by which routers simply follow that path and share information from source to destination. Okay, so the first step, the first routing protocol that we are implemented over this scenario, that particular protocol is static routing. Okay, so let's start configuring this routing protocol. Okay, so before doing the practical, I also explaining that the static is up to two types. One is next hop IP address, next hop IP address, and second one is the exit interface. Okay, so these are the two processes of configuring the static routing over the router. Okay, so what is it like? We have two types of cables majorly used in the network to share informations over the devices. So one is the ether type, one is the Ethernet, and second one is the serial. For Ethernet, we have to follow the particular step named as next hop IP address. Okay. If we want to configure the static routing process to share information from one network to another, and both the devices, both the routers should connected via the Ethernet cable, then we should follow the next hop IP address process to configure the path, and after successfully completing the path, devices can able to share informations with each other. Okay, so just follow this particular step. Okay, so here you also check one more point. This is also the very important point. If you want to share information from this network to this network, whenever you generate the packet, that particular packet goes like this. Like over this router, on fast Ethernet 0 by 0, it simply receives the packets, and over this fast Ethernet 0 by 1, it simply exit that particular packet. And after exiting the packet, it simply forward the packet towards its next router. And over this next router on the port fast Ethernet 0 by 0, it is simply receiving that particular packet that coming towards from router 1. Okay, so for router 1, the fast Ethernet 0 by 0 is a receiving interface. But that particular interface IP address is named as the next hop IP. See, it simply means that it is a receiving. It simply means that it is the receiving interface by which the router 1 share the information with router 2. Okay, and same like if you can see over this router 2. 1 minute, guys. I simply change the name. Like it's the router 2 and it's the router 1. Okay, now you can see it's router 1 and router 2. Okay, so and exactly for R2, when you generate the packets from this network, this router receiving the packets on the interface of fast Ethernet 0 by 1, and through this fast Ethernet 0 by 0, it's simply outsourcing the packet, and that particular packet is received by the interface faster than at 0 by 1 over this router 1. So that is named as the receiving interface of router 1, but that particular interface IP address is used as the next of IP address for router 2, by which it can simply forward the packet of 192.168.1.0. Okay, so let's configure that particular configurations. So to doing these things, then you have to go to the global configuration mode and you have to choose IP route and what about your destination network ID. So in my routing table, I already have I already had 10 and 192.168.1.0 information. So I need to configure 192 network information over this routing table. So I need to configure the network like 192.168.2.0 along with its subnet mask. After that, I have to choose the next of IP address. Okay, for router one, the next of IP address is the R2's sorry, the router 2's receiving interface is used here as its next of IP address. So the IP address of this particular interface is 10.0.0.1. And after completing this, so this is the entire command that you should use to configure the network 192.168.2.0 as its destination network over this router one. Sorry. Okay, press enter. Okay, just 1 minute. IP route 02.5.2.0.0.0.2. Okay. So now you can see show IP route. I simply show you the routing table. Like you can see now I simply get the routing table here. Okay, so you're gonna also do the same things here. So from this router, the target network is 192.168.1.0 because this router already has two network information. One is 10 network and second one is the 192.168.1.0 network. So to adding this particular network, you have to choose the following commands like 192.168.1.0, 255.255.255.0, and simply put the receiving interface IP address here. Okay. Now you also check its routing table. Then you also get I also get the static IP configured over this IP address. Oh, sorry, over its routing table. So now, if you want to share information from PC0 to PC3, then you can see it can ping in properly. It means that the reachability between them is successfully created, and now both are ready to share information with each other. Okay, now you can see it can ping in properly. Okay, so this is the first steps to configure the static IP address, so the static routing over the router, by which both the devices can able to share information with each other. Okay, so apart from that, you have to see router should follow some specific rules to share the information to its destination network. So that specific criteria is named as routing preference criteria. So you can see here is this criteria. The first one is the highest prefix value, which simply means that you can see here is the router. Here is a router, okay, which having two interfaces. Like over one interfaces the prefix value is 8 and this another interface the prefix value is 24. If you assuming that here is the packet coming to the router and router wants to share that particular packets over its one of the interface, then router firstly choose the highest prefix value as its base path. Like using this slash 24 path to sharing that particular packet. Okay, sorry, if you can see here in this situation router is definitely prefer the slash 24 path to share this particular packet towards the destination. Okay, because the slash 24 is the higher value, sorry, slash 24 is carrying higher prefix value comparison with slash 8. Okay, so this is the first criteria that say, router follows when it seems to be share some information to its destination. Okay, but here is also another possibilities like if we have the same prefix value over the routers, then at that time router also follows the second process which is named as the AD value. If the AD value carries the lower values, then that particular path is known as the best path for router, and it simply use that particular path to sharing the information to its target network. Okay. So like what is AD value? AD value stands for the administrative distance. Okay, which is specifies a range of values from 0 to 255, which simply means that lower value higher in trust. Like if the value is lower, like 0, 1, 2, like if the value is simply lower, that carries the highest trust, and if the value is higher, then it carries the lower trust. Okay, so here is some specific AD values according to the specific route. Okay, so this that specific value is named as codes of routing tables. Then you can see, one minute. Now you can see here is some specific codes used to identify what is the specific network. Like if you see the 10 network, then it simply carries that here is the C. C is represented that that specific network is advertised by its own interface fast Ethernet 0x1. And what about the another network 192.1.0? It is also described the same. It simply describes that that particular network is advertised by its own interface by which is faster than 0x0. But you can see when I configured the static routing over this particular network. Okay, so it simply use s value, uses code s means static. S is used to specify that that particular network is available in the routing table that configured by using the static routing protocol. Okay, so this is the specific codes that we are discussing during the sessions. Okay, so for now you have to understand that what is C and what is S. Okay, so as for the AD value concept, the AD values carries some specific values according to its code. Like if it is the connected, like if you configure any network on its interfaces over its interface, then router specify that particular network with AD value 0. Or if you choose the static value which having the AD value of 1. Okay, sorry, if you are implementing the static route on a router, then it simply carries the AD value 1, because router seems that if the particular path is configured by the administrator, then that particular network is sorry, then it simply makes the trust about that configurations. That's why it simply choose the minimum value, which is 1 for static route. Except that there is another process by which we for which devices can find the best path in between them. So that particular process is known as the dynamic routing. Okay, so to performing the dynamic routing, there are some dynamic protocols are used named as REAP, EIGRP, and OSPF, like this. Okay, so for REAP, the AD value, the code that used by the router in routing table is R, where the AD value is 120. For EIGRP, the code is 8, whereas the AD value is of 2. Like it simply uses two numbers to describe its AD value. One is 90 and second one is the 170. And for third protocol is OSPF, where the OSPF use the code O to represent that particular network advertised by the OSPF, and the specific AD value is 110. Okay, so in this AD value, it is also have the possibilities like there are two common there are two same AD values are present over the network, over the router. Okay, so at that case, then router if check the prefix value and the AD value both are same, so then it goes, then it simply moves towards the third preference criteria, which is metric. Okay, so metric is the process by which devices evaluated some specific values to choose its best path. Okay, for static the metric is 0 because administrator manually configure the path. So so doing these things, it simply ignore all the things. It simply enter the network, and that specific network is automatically advertised in routing table. Okay, so here we don't need any type of criteria to check to configure the to configure the static routing. That's why for metric, in case of metric, the static is always carrying the metric 0. Okay. Second thing is about the RIP. RIP is the dynamic protocol, and for dynamic protocol, they are definitely uses some specific values to calculate the best one. Okay, for RIP to do these things, they are using RIP is using a metric which is named as hop count. And the second thing is about the EIGRP, where the EIGRP is also a dynamic protocol. That's why it simply uses some specific values to calculate its base path. So to doing these things, the metric is composite K values. Okay, and for OSPF, the metric is cost, because OSPF is also a dynamic routing protocol. Okay, so these are the specific purpose of calculate the base path by using the metric. But when all the three criteria are same, then when the all three criteria are same, then it simply follows the four criteria, which is the load balancing protocol. By default, router load balancing, or sorry, perform load balancing over four networks. Okay, by first come first on basis. Like if you see all three criteria are remain same, then router simply receives four networks at a time by default, by which it simply share the informations equally among them. Like if you take the example, like here is the another network of slash 24, here is the another network of slash 24. So the prefix value is same, the first criteria is satisfied. Second is the AD value. If all the interfaces are configured over this router, over its router's interface, then the AD value is 0000, which is connected to AD value. That means that all the AD values are same. For metric, connected doesn't have the metric. That's why there are no metrics. Okay. So in this case, router simply perform the load balancing. Load balancing means it's simply considered which route is coming first, and on the basis of that, if this specific route is coming first and this is second, this is third, and this is fourth, it simply forward the packet. Like first packet comes to first route, second packet comes from second route, third packet comes from third route, fourth packet comes from fourth route, and fifth packet is also come from route 1, like this. So that particular process is named as load balancing. Okay, so if you want to enhance, or if you want to increase the receiving or to load balancing network properties, like by default the value is 4, it simply means that router can able to perform the load balancing over 4 networks. Okay, so you can see that if you want to increase this count, then you are definitely uh, perform these things. We are definitely increase the specific network value to doing the load balancing process. So we have to enhance that particular value up to 32. If we have 32 networks in our network, then we can also able to performing load balancing over them. But if we choose more than of it, then it doesn't possible like this. Okay. So this is the routers routing table preference criteria, by which router using these criteria to record the informations of the networks, and when it able to share the informations to its destination, then it simply follows all these criteria, and after that it simply allow the packet to its destination. Okay, so that process is known as the routing preference criteria. Okay, and we recently did the practical, which is named as the static routing by using the extra pipe address, and here is the commands. Like you can see, here is the commands. So simply using the specific commands to add your target network, okay, over the routing table of your router, and by follow this routing table, sorry, to follow this particular statement, router updates its routing table by its network ID that the user, that sorry, that specifically configured by the user. Okay, so after successfully done, after successfully configured the static IP routing over the router, then we can able to share information from one network to another. Okay, so guys, is there any doubts? Bhuvan, Kishore, sorry, Krishore, Bhuvan and
Hello.
Kishore. Yeah,
Yeah.
Bhuvan.
So
Yes, is
the slash 24 and slash 8 is only for the priority, right? There is nothing big in that.
actually slash 8 slash 24. These are the prefix value which is used to identify that there are the used network bits
Okay.
over this particular IP address. Like if you choose slash 8, then it simply means that over this particular network, the first octet is the only octet which is used to specify the network bits. Okay, and if you choose the slash 24, then it simply means that from first octet to third octet, they are all, sorry, these three octets are used to specify or used to identify the network bits. Okay, so they, sorry, that is the purpose by using the prefix value. That particular value is used to identify the network bits present over the particular IP address or the particular network. Okay.
One more thing. Can you show your screen? I have one question.
Yeah,
How did
definitely.
you assign that?
Yeah. Yeah, Kishore.
Go to terminal. You assigned one IP, right? 10.0.0.1.
Yes, this is the IP address for the interface fast Ethernet 0 by 1. Like here is the IP address. This is the interface fast Ethernet 0 by 1. Okay, so I choose the specific IP address 10.0.0.1 for this interface along with its subnet mask. Then simply write the command no shutdown to allow the line protocol.
So the
Okay.
router, okay, router 1 is 0.1, router 2 is 0.2.
Yes, if you want to choose the IP addresses like 10.0.1 for router 1 and 10.0.0.2 for router 2, then you have to do, if you want to do this thing, then you can easily do it. It's totally depend upon you. If you want to reverse the IP address, like if you want to configure 10.0.0.21 router 1 and 10.0.0.1 over 2 over the router 2, then you will also do the things very easily. Like you just have to choose a particular interface and you just simply configure that particular IP address that you have to, sorry, that you need to configure over this interface. Then you simply choose that particular IP address. That's it.
Okay.
Any doubts? Guys, give me 2 minutes. Hello. Hello, guys.
Yes,
Am
sir.
I audible? Yes. So, yeah. So for here, do you have any doubts, guys?
No.
Do you have any doubts? Bhuvan, Kishore?
No.
Okay. So I give you all the commands like this. You simply, I think, Bhuvan, you already did
Yes,
this
sir.
configurations last class. Bhuvan?
Ah,
We simply did this configurations on your last class.
Yeah, yeah.
So okay, so you just need to configure the single state line. Sorry, in the single state command, which is the static routing command. So you simply choose this command. Okay,
Okay.
okay. So I just give you 10 minutes. Okay, so just simply configure all the things, and after 10 minutes we are moving towards the another configuration, which is static routing by using the exit interface. Okay, we just simply change the cable into ethernet to the serial medium, and after that doing the configurations accordingly. Okay, so Krishore,
Yes, sir. Yes, sir.
if you note all the commands properly, then you also do the practical. Okay, I will give you 10 minutes. Okay,
Okay, sir.
okay. Hello, Bhuvan. Bhuvan,
Yeah.
are you done?
No. I'm just trying.
Okay, okay, okay. So, do you need some time?
Yeah.
You need some more 5 minutes? Okay, okay. You just take your time.
Okay.
Need my screen shared?
No, not required.
Okay, fine. Bhuvan done? Bhuvan
Yeah.
done?
No. I'm just doing the first session only. I'm trying.
Okay. Bhuvan, you just do one thing. You
Okay.
simply share your screen. I also check your configurations. If there is any problem that you are maybe facing in your during your configurations, I need to help you. Okay.
Okay.
If you need my help, then I will help you. Okay. So just
Okay.
share your screen.
It's visible.
Yeah. Sorry, but screen. Yeah. Okay, so Bhuvan, you just clicked over the real-time mode. That particular option is situated just exactly on the right bottom side. Right bottom
Okay.
side. You just click over the real time.
Okay.
Okay. Actually, your screen is not moving. Sorry, but Bhuvan,
Ah,
what is your full name?
Bhuvaneshwaran.
What? Sorry, do I know about your name like Bhuvaneshwar?
Bhuvaneshwaran. Yeah. Correct.
Yeah. Okay, Bhuvaneshwar. Actually, I am from Odisha. Okay. So the capital of Odisha
Okay.
is
So you know
Bhubaneswar.
that. Yeah.
Okay. So I'm also belonging from Bhubaneswar. Okay. That's why your name is like Bhubaneswar. So, Bhuvan, I think that your internet is maybe slow.
Yeah. It's very slow.
Okay. Okay. Again, not an issues. Actually, your screen is visible, but whatever you do on your screen, I literally can able to see that. Okay,
Okay.
that's
So
why. Okay, you just did your thing. I think that you successfully. Oh, okay. Now it's fine. Now it's fine. Now it's fine. Okay, now you simply do. I think that you got all the green signals. Okay,
yeah.
so okay, so just configure the default route.
Suppose I want to assign IP. Just what to do?
What?
IP is assigned at. Suppose
If you
I
want to
want to
assign it,
assign static IP.
okay.
Static
So
IP.
you just configure. Sorry, you just click over the router.
Okay. Router.
Yes.
Then
And what is your destination
next.
network? Okay, so just go to its global configuration mode. Go to its CLI
How?
mode. Yes,
Where?
just yeah. Click over the router. Go to its CLI mode.
Okay.
Okay, okay. Just simply enlarge it, like maximize it. It is not visible clearly to me.
Wait. Okay.
Yeah. Thank you, Bhuvan. Okay, press enter multiple times. Okay,
Okay.
fine. Now you write the command enable,
Enable.
enter.
Enter.
Here you have to choose the command config terminal,
Config.
config space terminal, then
Okay.
enter. Then you have to
Okay.
choose here the static route. The command is IP space route.
IP space route.
Okay,
Okay.
space
Is it complete?
next. Yes. You
Okay.
write the
Sorry.
line. Actually, this command is not completed. So
Okay.
you choose the command. Okay, IP route. Then you choose your destination network. What is your destination network that you want to share that particular information? Yes.
Okay. But I still not defined any how to close this.
You just minimize it. Minimize it. You just minimize it.
So
Okay, what is your target network?
I still not defined any network. Just I created all the images only.
Okay, I can understand it, but about your, oh, sorry, these three systems like PC0, PC1, PC2,
Mm-hmm.
this is a network, and also you configured PC3, PC4, and PC5. This is the another network. Okay,
Yeah, correct.
so for the router 0, okay, so the destination network may be the PC3, PC4, PC5. These three PCs are configured in those network. Maybe this network is your target network. Am I right?
Correct, correct.
Okay. So what is its network ID? Just go to its routing table, like clicked over the router one, clicked over the router one, router one, like the other side router. It's router one.
Mm-hmm.
Yes, one. This is the router one. Okay. You simply press multiple enters. Okay. यहाँ पे sorry. So write here enable.
Okay.
Then write the command config terminal. Sorry. Stop here. You just choose the command show IP route. Show IP route. Show space IP route.
Okay. It's showing empty.
Show IP space route.
Mm.
ICMP default get is not set. Show IP route. Oh, you choose the command like show IP interface brief. Show
So
IP. Show
IP.
IP
Okay.
interface brief.
Interface. So IP interface. Then
Brief.
BRIEF, right? Invalid and
Show IP
created.
inference. Sorry, it is a spelling mistake. It's
Okay.
interface. Yeah, it's interface. Interface brief. Enter.
Mm.
Okay, just a minute. Okay, you didn't configure IP address over the interface yet. That's why it shows like you don't have any network information in your routing table.
Okay.
Okay.
How can? Okay. Tell me how
Okay.
can I assign the?
Hmm.
Suppose I
Bhuvan,
want to. Uh,
you just stop sharing your screen. Okay. I do the configuration just in front of you right here, right now. Okay. You just follow all the commands and note it carefully. Okay. And after that, you did, sorry, after that, you will try this particular practical. I think that you definitely do the practical. Okay. Okay. So, first of all,
mm.
okay, you choose the router is 2811 of
Wait.
whenever you click the yes. Okay.
So it should be 2811, right?
Yeah, 2811.
Okay.
Okay. So apart from it, like you just configure your LAN network
Uh,
regard with its network like this. Here is my network ID is 192.168.1.0 and another network is for 192.168.2.0. And I also choose a network to configure both the connected interface between the both routers. That particular network is 10.0.0.0. Okay. So like this, you have to choose the specific networks to configure your network. Okay. So you just simply draw a map in your mind like this. Okay. After that, you choose the first router, go
okay.
to its CLI mode,
Okay.
And after CLI mode, here you write the command no. Okay. After no, you simply get the user interface mode, which is router greater than mode. Here you write the command enable, then press enter. After that, you will get the router hash mode, which is known as the privilege mode. Okay. So here you write the command configure terminal present. Okay.
Okay.
So at this mode, you first need to configure the IP address
Hmm.
to the network, according to the network that you have in your scenario. So you can see for the LAN network, like the fast Ethernet 0 by 0 that connected with the switch, and also the switch is connected with these three phrases. Then this entire LAN network is need to be configured by using this network 192.168.1.0. Okay, so you just choose an IP like interface fast Ethernet. Okay, 0 by 0. You first choose the interface, then write the command IP address, and I choose an IP, like I choose the IP 1.10 with its subnet mask, and write the command no shutdown to enable the line protocol. Okay, you can see I successfully activate the line protocol and also configured the IP address over this interface. Okay, if you see it carefully, then I simply write the command exit. Exit is a command by which after successfully after successfully done the IP addressing process in between over this interface, then I need to be exit this soft configuration mode of the interface. That's why I write the command exit. Okay. So here you choose, here you choose the another interface, which is the fast Ethernet 0 by 1. Okay, available in the other side. And for configure the IP address over on it, we have a network like 10.0.0.0. It is a 10 network. So you choose an IP address by this network. Okay, by using this network. So I choose the network guide like 10.0.0.1. So first choose the interface like interface fast Ethernet
Okay.
0 by 1. Okay, then do the same things. IP address that 10.0.0.1 to 555.0.0.0. Then write the command no shutdown. Press the command exit. Okay,
Okay.
so now you successfully did the IP addresses, or you successfully configured IP addresses over the interfaces of this router. If you want to check the status whether we configured the IP address or not, then you simply write the command exit here, and it simply pull you in the mode which is under the privilege mode. And this over this mode, we are able to check all the configurations that we did in our system or in our device. So here you write the command show IP interface, show IP interface brief, sorry, interface brief, and you can see I have two interfaces, and now I able to configure the IP addresses properly, and the whole status and the protocol is successfully activated. Okay, you can also say that maybe here the protocol is down. Actually, it shows down, but actually it's up. If you want to check, then you can see. If I simply configure the IP address over this interface of routers 2, and after configuring the command no shutdown, then that particular port of fast Ethernet 0 by 1 is successfully activated by default. Okay. So to doing these things, I choose the same things. I already did the same things here. I just do the same things here, like configure terminal, then interface fast Ethernet 0 by 0. I enter the command 10.0.0.2 with the subnet mask, and here if I if when I write the command no shutdown, then you can just see what happened. If I press the enter command, now you can see automatically the fast Ethernet 0 by 01 port status is now okay, now is up. Okay, so and also over this interface we also get the port successfully activated. Now press the command exit and go to the another interface 051 IP address 192.168.2.10 or 255.255.0. Then the command is no shutdown. Okay.
Okay.
After that, you have to check the routing table. Like press go to the router. Sorry, go to the router and write the command show IP route. Here is the command to check the routing table, and you can get the routing informations over on it. And you also do the same things here. There's the exit command. Let's check the command like show IP route. You also get the same things. Okay. Apart from it, you have to choose. You need to configure the default route. Okay. So before I do the configuration, I think you need to do the configurations. Okay, like this. After done these configurations, I will teach you how to configure the default route. Sorry, how to configure the static route over the router. Is it fine?
Oh, fine.
Okay, fine. So let's do it. Bhuvan,
Oh,
just sharing your screen with me.
okay. Wait.
Yes.
Is it visible?
Yeah, it's visible. Thank you. And now you just do the practical.
Invalid interface type and number. Actually, I did not get.
You have to change the router. You have to change the router. Okay. If you want to know what is the interface type, then you simply activate some commands. Like you just clicked over 1 minute, 1 minute, 1 minute, 1 minute. You just clicked over the option, like exactly the Apple logo. You have the command Cisco packet tracer, then file, edit, then options. No, 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 not there. Here is options. Okay, options, just near to the edit and view, just middle of edit and view, you get the option there.
Mm.
Options, yes, options.
Okay.
Then you go to, no, you just write, sorry, you just clicked over the view, just
Okay.
near. Actually, you get the preference command here. No, you just clicked over the edit, choose the edit,
In
edit. Actually, it
edit
is
also there
Apple.
is no prefer.
No preference. I
Yes.
think,
So
yeah, you
wait,
just
wait.
click
Let me check.
edit. Oh, 1 minute. Here. You can see here is the preferences about the Cisco packet tracer. You get, yes. You have to choose like the customized user experience. Then you can see the show animations, play sound. In this line, you choose the fifth number options. You just ticked on it. Fifth number. Always show port levels in logical workspace. Yes. Just tick mark it.
Then
Then cancel it. Let's cancel this tab.
okay.
Right,
So I close
left
it,
side
right?
top
So
corner.
just close.
No,
I'm
simply
closing
cancel it.
it.
Okay. Yes. Now you
Ah,
can
okay.
see you get the informations. Okay, so you just change
Yeah.
the router first. You just change the router first. Actually, this is not the two-way WLAN router. Okay, it is a different model router. So I think you have to change the router.
How can I delete that?
Okay, you can see your on your left side corner. Then you get a magnifier option like the source option. Then no. Like the third option in the same line. Yes,
Okay.
this is yes. You just clicked on it and yes, done. And press the escape button on your keyboard. Yes, done. Then choose the router.
Hello.
Yes,
Yeah,
one.
what is wrong in that command? It's showing.
1 minute. Um, it is the fast. No, okay. You choose fast internet already, and you can write the command fa. If you choose the entire command, yeah, after choosing the entire command, you just enter the value 0/0 like this. You choose the fast Ethernet as well as you choose the short form of FA00. You write the command interface fast Ethernet 0/0. That's it.
Okay, wait. Done.
Yes, 0/0. Choose the command 0/0.
Okay.
If you want to choose the short form, then you simply write interface FA0/0. Yeah.
Okay, it's correct. Okay. Done. Shut down.
No, 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 no. One, you type the
Ah,
command. 1 minute. You have to choose the command exit.
okay.
Yes, write the command exit.
Then
Then exit. No. Then exit.
okay. One
And
more
here
exit.
write yes, one more exit. Then write the command show IP interface brief.
Okay. Ah,
You get your answer?
ah. Okay. So
But you don't configure IP address on the port faster than 0 by 0. Why?
sorry.
You don't configure the IP address on the port faster than at 0 by 0. Like you can see
Zero
in
by
IP
zero.
address section, it is unassigned. It shows the IP address is unassigned on the port faster than at 0 by 0.
But I said no. Fast is
But
0 to 0. I assigned. You can see here.
yes, actually you entered a wrong IP on this port. Yes, it is the far. Okay, you choose the IP address like 192.168.1.0. Actually, it is not a IP address. It is a network ID. So you choose a valid IP address like 1234, like 1 to 254. This is the range of IP
Okay, I
addresses
had.
that you get in this. Yes. So you choose an IP address.
Okay, wait. Let me try it. So what is the command name? Interface. I need to select the interface, right?
Interface, yes, interface and write the command IP address.
So I need to give the 192.168 1.1, right?
Yes. Okay, no, no, no. You just write the command config terminal to go to the global configuration mode. Write the command config terminal, config terminal.
Uh,
After that, you choose the interface faster than at 0 by 0.
Now both are up, right?
Yeah, it's fine.
So the same config.
Yeah, no, you just
Same.
do the same process. You follow the same process, but don't choose the same IP address
Okay.
on its other side. Okay.
Okay.
Over the second router, you choose the specific values. Okay, I just share my screen. Okay, you just check the network. Okay, what are the networks that I use to configure the devices? Okay, according to this network, you do your configurations. Okay. Okay, so do you see my screen? Is it visible? Bhuvan?
Visible. Ah.
Okay, fine. Okay, fine. Bhuvan done? Bhuvan?
Yeah. Hello.
Done? Done? Yes, done.
Yeah. Second router is configured.
Okay,
And,
okay, okay. So just share your screen.
wait.
Okay. So
Showing.
just open, yeah, or just choose the. Okay, fine. Yeah, it's done. 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 Cancel it.
Uh,
Okay. So now you have to choose your destination network. Okay. So you can see if you want to share information from PC0 to PC3. Okay. So the PC0 is configured. Okay. So you forgot to configure the IP address over the devices. Okay. You just click
sir,
on
wait. I
it.
am almost. Yeah, IP is configured.
Okay. So Bhuvan, you also configure the default gateway.
Default gateway. I did not configure.
Default gateway. Yes. Yes. What is the default gateway? The router's interface fast Ethernet 0 by 0's IP address is configured as default gateway IP on the device PC0, PC3, and sorry, PC1 and PC2. The first router's interface fast Ethernet 0 by 0's IP address is used as a default gateway for the PC0, PC1, and PC2.
Where I can configure that one default gateway. I did not configure that.
Yes?
I did not configure that.
Oh, so you just do the configuration.
Hello.
Yes.
Yeah. How to
What is the how to configure default gateway? Okay. So you check the IP address of fast Ethernet 0 by 0. What is it?
this one?
Yes, this one's interface fast Ethernet 0 by 0. What is the IP address on it?
IP address it is for router one. It is 192.168.1.1.
Okay, so this is the default gateway IP address. Though you use this particular IP address as default gateway IP address for these PCs, PC0, PC1, PC2.
Hmm.
Just clicked
So
over the PC0. Okay, you just clicked on PC0.
okay. Okay. Then default
Then
here
no,
I
no, no,
should.
no. Actually, I'm not. Oh, okay. Just clicked on the PC0. Actually, I'm not able to see your screen. Okay. Yeah, default gateway. Fine. Fine. Done. And do the same things over the remaining devices. I think you choose same IP addresses maybe. No, 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 it's different. So for PC3, PC4, PC5, you choose second routers fast Ethernet 0 by 0's IP address as default gateway.
Yeah. Second one is different.
What is the IP address? One dot. Sorry, you configured 1.2
1.2.
on it. No, 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 no. How is it possible? If you choose here is the one network, then the other side you have to choose the different network, na?
Okay. So I need to change
2.0,
that.
192.1 2.0, 1. Yeah, yeah. You have to change that IP address.
Wait, I'll change.
Bhuvan done?
Uh,
Hello.
uh,
Oh,
uh, uh,
sorry, I'm not able to hear you.
audible?
Yeah, now it's fine.
Hello.
Yeah, just check your configuration. Is it done?
Uh, so,
एक बंदा है जो क्लास ले रहा है वो भी डिस्कस कर रहा है टेक्नोलॉजी पढ़ाया था कुलदीप को कुलदीप हाँ बाय कहाँ पे मेरी क्लास में बैठा था अभी चले गए बैठा हूँ चले गए नहीं बैठे हैं बाहर बैठे हैं हेलो हेलो भुवन हेलो
yes, done.
Yeah, Bhuvan done. Okay, Bhuvan just
Hello.
Bhuvan just give me 2 minutes, guys. Just give me 2 minutes. I need
Uh,
to actually nature calling. Just give me some time. Okay.
okay, okay. Hello, Trisha. Hello.
Hello. Hello. Guys, am I audible?
Yes,
Hello.
audible.
Yeah, Bhuvan. Bhuvan, you successfully. Okay, distance one. Okay. So you changed the network of the. Hello, Bhuvan. Did you change the
Uh,
network? Okay. So just
uh,
okay. Okay. So just
yeah, tell me.
click over the router and write the command show IP interface grid.
Okay.
I need to verify the network.
So IP interface, right?
Yes. Here you have to choose enable command. After that, in hash mode, you have to Mhm.
Enable.
enable. Enable. Write the command enable.
Then
Write the command enable. And write the command show IP interface brief. Show IP interface brief.
mm,
Hello, Bhuvan. Your screen is yeah. Actually, I am not able to see your screen properly. That's why I repeat the things. Write the command enable. Sir, hello, hello. अगर पंकज सर को बुलाना, मैं थोड़ा जल्दी बुला रहा हूँ। पंकज सर को बुलाते। हाँ Bhuvan.
Yeah.
Yeah, Bhuvan. Share your screen. Share your screen. Yeah, Bhuvan. Share your screen.
Okay.
Okay. Bhuvan, on another router,
Okay.
you just open the another router and run the command show IP interface brief.
Yeah.
Okay. Yeah, now you can get. Okay. So you can see for your PC0, if you want to share information from PC0 to PC3, then PC0 is configured on the network 192.168.1.0, whereas the PC3 is configured over the network 192.168.2.0. Okay. So now, if you check the routing table of this router, then you can get two networks informations on it. One is the 192.168.2.0 and second one is the 10.0.0.0. Okay. On your router 2, if you check the router, then you also get the routing information on on its routing table. That is 192.168.1.0 and second one is the 10.0.0.0. So first click on the router 2. One, click on router 2 and try it. Yes, and check its routing table by using the command show IP route.
Okay. So IP route, yeah, it's showing 10.0.0.0/8 is disconnected. That's directly 192.168.0.2.0/24 is directly connected.
Okay, so now I sharing my screen. Okay, you just check the screen. Take a minute, guys. Okay, so now you can see Kishore. Bhuvan. Yeah, Bhuvan. So now you just see my screen. You simply use the command over on your system, like on your router 2, you just write the command IP route specify your target network like 192.168.2.0 along with its subnet mask, and write the receiving interface IP address, which is the router 3 is receiving interface IP address. Like for me, the IP address is 10.0.0.2. Press enter. And for the router 2, I choose the same command like IP route.
Hello.
Yes, hello.
Tell me that router 2 command, IP route.
IP route, okay. Bhuvan, I need your screen. Sorry, I need your screen. Because without your screen, I don't
Okay.
understand. Yes, I don't get the information.
Okay. Right.
One minute. I'm still not able to
Okay.
see your screen. Well, literally, I'm not able to see your screen yet.
Is it visible now or still not visible?
No, Bhuvan. Bhuvan, you just okay. Bhuvan,
Okay.
you just reshare. Yeah, you just reshare it. Maybe I get your screen.
Wait.
Okay, leave. Bhuvan, I just yeah. Okay, now your screen is trying to visible me, trying to visible in front of me. No, Bhuvan, stop sharing your screen. Okay, I simply explaining. Okay, yeah, I simply
Okay.
explaining. Just give me some time. Okay, now you can see for this network. Okay, for this network, okay, this is your target network. Like if you want to share the packet from pc0, then it is your source network and it is your destination network. Okay, so for this router you need to configure the route for the network 192.168.2.0 by using this receiving interface IP address as a next of IP address, as a as a next of IP address. Okay, Bhuvan, first step is clear. Bhuvan,
No, tell me once again. Sorry.
okay, once again. If you want to share information from PC0 to PC3, then if the packet
Okay.
source is PC0 and the destination is PC3, so you need to
Okay.
configure the destination network over this router. So
Okay.
you choose, choose the network like this, and along with the network, you choose the subnet mask like this, and you also choose the next hop IP address, which means that if you exit the packet from this interface, then here is the interface named as fast ethernet 0 by 0, which is receive that packet and forward towards its destination network. So that particular interface is named as exit interface, or sorry, receiving interface of router 2. So you just configure this interface IP address as a network, as a next hop IP address over this IP address. Like simply you just write the command IP route
Okay.
IP route, and the destination network is 192.168.2.0 along with its subnet mask. It is in single line, okay? And you
Okay.
choose the next up IP address of this interface IP address, which is the fastest 0 by 0, okay? So which is 10.0.0.2 on my scenario, okay?
Okay. Okay.
On if you do it in reverse way, like if you want to show share the information from this network to this network, then over this router, you need to configure the destination network as 192.168.1.0, where you throw the packet from this interface. Then over the router one, the fastest thread 0 by 1 is the receiving interface. Okay, so you choose this interface IP address as next up IP address to configure the destination network as 192.168.1.0 over the PC2. Oh, sorry, over the router 2.
Okay.
Clear? Like the command is IP address. It is a command for router 2. I command for IP address. Sorry, IP route. Sorry, I use the wrong command. Like I use the command IP route, and then the destination network like 192.168.1.0, and what is its subnet mask? Like subnet mask is 255.255.255.0. Along with this, you should need to define the next hop IP address. The next hop means the neighbor routers, and what is the IP address? Now the IP address of its receiving interface. So this interface IP address you used as next hop IP address. So you simply write the IP address here, which is 10.0.0.1. This is the hold command that you use to configure over the router. Okay, now you can see I simply did the same thing here. Okay, here is the network like IP route. The target network is 192.1.0, and this is the subnet mask, and it is next up IP address. Press enter. After successfully done, you get the information like this on your routing table. Okay, like this is the starting information that you get. Now, if you ping from PC0 to PC3, now it is pinging properly. You can see the first packet and the second packet will be dropped, and remaining are pinging. Oh, let's drop 3 packet. Okay, now you can see it's pinging properly. Okay. Okay, everyone. So I think today, yes, yes, everyone. Hello, hello. When do I audible? Yeah,
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 I
woman.
did.
Yeah, okay, okay, woman. So did you understand this topic?
Yes, I understand.
Okay, so after ending the session, I will share the recording with you. Okay, so just take some practice on it, and for tomorrow we are discussing for further concept regarding the routing protocols. Okay, okay. So for today's, I end the session now. Have a good day, guys.